Leading stock technical indicators are used to lead price movements by identifying their momentum as either the tendency of rising prices to rise further or falling prices to fall further. Most of them are either centered or bounded oscillators and consist of average directional movement index, commodity channel index, moving averages convergence divergence, commonly known as MACD, rate of change, relative strength index, stochastic oscillator, and Williams percentage R, among many others. Average directional movement index is a bounded oscillator that measures a stock price trend's strength and momentum. 14 days are commonly used for its calculation. For full reference, I recommend that you read Vélez Wilder Jr., New Concepts in Technical Trading Systems, published by Commodities Magazine, now Futures Magazine, in 1978. Its calculation has the following steps. A. Daily true range, positive and negative directional movement calculation. Daily true range is equal to the maximum between high minus low prices, the absolute value of high minus previous close, and the absolute value of low minus previous close. Daily positive directional movement is equal, and we ask if the current high minus previous high is greater than previous low minus current low, then the corresponding daily positive directional movement is equal to the maximum between the current high minus previous high, or zero. Else, our daily positive directional movement is equal to zero. To calculate the daily negative directional movement, we ask if previous low minus current low is greater than current high minus previous high, then our daily negative directional movement is equal to the maximum between the previous low minus current low and zero. Else, our daily negative directional movement is equal to zero. B. 14-day smoothing with Wilder's techniques. First, we have the corresponding true range for 14 days, which is equal to the previous 14 days true range multiplied by the previous 14 days true range divided by 14, and this then we add the corresponding daily true range. For our initial 14-day true range, it is equal to a 14-day simple moving average of daily true ranges. We do the same smoothing with Wilder's technique for the 14 days positive directional movement. And also, we do the same smoothing with Wilder's technique for the 14 days negative directional movement. C. 14 days positive and negative directional index calculation. 14 days positive directional index calculation is equal to the absolute value of 100 multiplied by the 14 days positive directional movement divided by the 14 days true range. The 14 days negative directional index is equal to the absolute value of 100 multiplied by the 14 days negative directional movement divided by the 14 days true range. The 14 days directional movement index calculation. 14 days directional movement index calculation is equal to 100 multiplied by the difference of the 14 days directional index divided by the sum of the 14 days directional index. The difference of the 14 days directional index is equal to the absolute value of the 14 days positive directional index minus the 14 days negative directional index. And the sum of 14 days directional index is equal to the 14 days positive directional index plus the 14 days negative directional index. E. 14 days average directional movement index calculation. The current 14 days average directional movement index is equal to the previous average directional movement index of those 14 days multiplied by 13. Then we add our current directional movement index of 14 days divided by 14. For our initial 14 days average directional movement index, it is equal to the 14-day simple moving average of the corresponding 14 days directional movement index. Great, so let's go back into our Python PyCharm IDE so that we can study average directional movement index with greater detail. Excellent, so here we are back within our Python PyCharm IDE. In this lecture, we'll be working within average directional movement index code file. If you have any questions about its setup, please go back to section 1, stock technical analysis data lecture, where all of that explained with greater detail. So as all of these are meant to be standalone type of files, first we do our packages importing, numpy as mp, pandas as pd, matplotlib as plt, and talib as ta. Then we proceed to do our corresponding data reading. For this, we create spy, data frame, which corresponds to the Standard & Poor's 500 ETF, and we do it with pandas or pd.read_csv, the path to our data file, which is located right over here within the data directory we created, and the text file. This includes CSV or comma separated values, and here we have the index column as date, and we parse those dates as true. Next, we proceed with our technical indicator calculation and its associated chart. For this, we're going to create 3 columns within our original data frame. One for the average directional movement index, then one for the positive directional index, and another one for the negative directional index. All of them are calculated with talibs, TA, the first one with ADX, the second one with +_DI, and the third one with -_DI. For all of them, we are providing NP numpys as array, high, low, and close prices. And notice we are defining again the time period for 14 days, which is commonly used for its calculation, but again can be modified according to your needs. Then we have the technical indicator chart, which is fig1, AX for axis equals plt.subplots. And notice the difference. Now we have 2 subplots because these are oscillators which are charted below our prices. Therefore, these 2 subplots, they share x-axis as true. Then we have on the first one, which is at axis located at position 0, which we can see here within brackets, we plot close prices and their legend located at the upper left. Then on the first chart, which is a chart that's below, we're going to plot our average directional movement index, our positive directional index, and negative directional index, and we're going to add their legend located at the upper left as well. Then we're going to add PLT superior title. Notice that's not title, it's superior title, so that it does it above the 2 subplots. And we're using SPY, close prices, and average directional movement index ADX of 14 days, and we show the chart. So let's proceed to run the code by clicking the right button on the mouse and scrolling down into Run Average Directional Movement Index. Excellent, so here we have our 2 charts. So let's make it a full screen manually because of the screencast from here to here and then right over here. Perfect. So we have SPY close prices and average directional movement index ADX for 14 days. On the first of our subplots, we have our close prices, vertical axis. Then on the next one, we have our technical indicator. Both of them share the horizontal axis, which is dates from the beginning of 2016 to the beginning of 2017. So as mentioned, the blue solid line at the top is our close prices, and in our technical indicator, we have a solid line our average directional movement index, then we have in orange our positive directional index, and then we have in green our negative directional index. As we'll see in our following section, the combination of these 3 generate their associated trading signals, which we'll study with greater detail later on. So let's close this chart as well as these other charts, which will also be studied in following sections. Excellent. So now that we've finished with our corresponding average directional movement index, it's time to continue with the next of our leading type of indicators. In this case, we'll study the commodity channel index, and that is going to be our following objective.